Okay, dude. So check this out. This is essentially that schematic that I posted on the video I did the other day with that overdrive pedal, talking about how you don't get clean boost, adjustable clean boost, I should say, by putting an overdrive pedal in front of your amplifier. So what I've done is I've taken that schematic of the do you mind, fucker? I've taken that schematic and I've removed the clipping diodes because they do make it kind of a bit more difficult to calculate this by not being able to, you know, have different levels of output and all that junk. Make sure we got a good signal here. Not too worried about the yellow signal on there because that's just our input signal, so it's really small, so it'll appear to fluctuate and everything. And it's just because it's so small that everything's really sensitive on it. Well, our primary focus is this output guy. As you can see right here, it's completely unloaded, so it's not trying to deliver any power to anything. And there's not a lot of power going to this thing anyway. You know, it's 9 volts. It's really designed to be a very low power system. However, you can still pop a load on it and see how it responds to a load. Now, I've got a few different resistors here that'll all act as a load onto this guy. Make sure we got a signal going through. Jesus Christ, the breadboard's really old and starting to get not quite as good of a fit for things. So apologize if I lose my signal a few times, but here we go. So you can see I'm plugging this resistor into the output pin here, and I'm going to feed that to ground, so it's going to act as a load onto the system. Now look at this at the output. You notice compared to the unloaded, the load's plugged in. Don't plug it into the positive, that would be bad. But load's plugged in, and you can see as I unplug it and I plug it in, you don't see a big voltage drop. Now, I'm not sure if this is the well-matched one. I've got some that are close here. Let's try this other one. See what happens with this one. I think that was the well-matched. Oh, look what happens with this guy. I pop him in there. And I put him in. Look how quickly that signal drops. Look. Out. No load. Load. No load. Load. No load. Load. Now, let's check out this one. This is this one I actually did do a measurement on. It's 220K. I'm expecting that to be way higher than my output impedance. So I should see, oh, look at that. No load. Heavy load. No load. Heavy load. Now, just for fun, let's take a look and see what happens if I put a really small resistor in here. So as you see, the one of these 4 randoms, this one right here is the well matched one. Let's see if I can go ahead and get me a really small resistor. Let's see what we have for small resistors here. So, for small resistors, right? I have values ranging from 1 ohm to 1.8 ohms. So, I hope I don't well, I'll probably fry the resistor I pop in here, but it's worth it for science, right? So let's see what happens. Get out of here. So, plugging it in here. And we connect to load. Look at that. Look at that, my friends. What do you see here? I have something that's between 1 and 2 ohms going through here. And what does our output look like? Absolutely nothing. So, as I said before, power transfer rule, right? You can see that the purple line here, that's our output signal. When I put this very low resistor across here, right there, you can see it coming there, acting as a load, right? Watch this. This is the only thing I change. Bada bing, bada boom. See if you can see them both at the same time. Oh, line that up, right? All right, now let's see if you can see it. Let's see if you can see it. See if you can see it. Line up the shot and boom. You see how that worked? Maximum power transfer. It's the Thevenin resistance that you use to determine which amount of load is used to go with the speaker, with your amplifier. Now, we don't always get perfect matches, right? And you know this because, you know, we live in the real world. Not everything is a perfect match. But the closer our values are to our desired values, the better we get for our power transfer. You can't just say, oh, I've got an 8 ohm load, I can pop a 4 ohm speaker on there and get double your power. It doesn't work that way.